Yes, welcome back again to this tutorial. So last time we were looking at resolution of forces, how we can calculate or how we can get the resolution of a system of forces. So we had already looked at parallelogram and triangle method. So these are graphical methods whereby you can measure, you can use scales in order to get the direction and magnitude of a resultant force. Then today we are going to look at what is called the analytical methods. So here we are going to measure on cosine and sine rule to get the resultant of a force. Then thirdly we shall look at resolution of a force. So in parallelogram law of forces, we are generally talking about the cosine and sine rule. So remember, we had tackled this but in graphical method. So let's look at what is our parallelogram, or rather what does the parallelogram uh, law of forces state. So it states that if you have two forces that are acting simultaneously on a particle, be represented in magnitude and direction by the two adjacent sides of a parallelogram, the resultant may be represented in magnitude and direction by the diagonal of the parallelogram, which passes through their point of interaction. So mathematically we can represent that by this equation here, whereby R is the resultant force. And to get the resultant force, we have these two forces, that is F1 and F2. So this is a general formula for getting the resultant force. So F1 and F2 are the forces that we are getting their resultant. And we have theta. So theta is the angle subtended in between these two forces, F1 and F2. Now if you want to get the angle between any of the forces and the resultant force, you have tan theta is equals to F2 sine theta over F1 plus F2 cos theta. So just to explain all of this, we are saying if we have two forces, let's say this is F1 and its magnitude is equals to 50 newtons, and then we have F2 and its magnitude is 40 newtons. So the angle subtended in between is maybe, let's say, 60 degrees, and we call this theta. So if you want to draw a parallelogram, you see you'll have to draw a line which is parallel to this but starting from this point, and also a line that is parallel to this and starting from this other point. So to get the magnitude, we'll run from this end, that is from this point here. So we say this is O, this is A, and this is B, and this is C. So the resultant of these two forces, that is F1 and F2, according to this statement, that is the parallelogram law of forces, it means that we have the resultant force running from a point of intersection through to the other end. So we have the resultant force here. So this angle here, alpha, represents the angle in between F1 and F2, the two forces that we want to get their resultant force. So let's go ahead and look at one example of how we can tackle these problems that are, or rather we can get the resultant of a force using cosine or sine rule, and also looking at the parallelogram law of forces. Here is a quick example of what we have just covered previously. So we are going to look at how we can get the resultant of this equation. So the question reads, two forces of 100 newtons and 150 newtons are acting simultaneously at a point. What is the resultant of these two forces if the angle between them is 45 degrees? So the first thing that we are supposed to do is to draw a diagram that will guide us on how to work out this problem. So we say these two forces are acting at a point. So let's say this is the point, let's name it P, or rather O. So we have one force. I want to let it be on the horizontal axis, so I'll call it F1, and its magnitude is 150 newtons. Then we have another force, which is F2, and its magnitude is 100 newtons. So we want to get, so the angle subtended in between them is 45 degrees. So we are being asked what is the resultant of these two forces if the angle between them is 45. So what do we, if we can remember this equation, R is equals to square root of F1 squared plus F2 squared plus 2 F1 F2 cos theta. So we already know what is F1, F2, and then theta. So you can directly go ahead and substitute whatever you have in this equation. So you have square root of F1 is 150 plus 100 plus 2 into 150 times 100, then you have cos 45 degrees. Now R will give us, so if you look at this 100 squared, 150 squared is 100 squared plus 2 times 150 times 100 times cos 45. So that will give us 553,713.20344. So when you get the square root, we get to 31.76 newtons. So this is the magnitude of the resultant of these two forces. So that's simple.